YouTube. Hello, everyone. This is Mr. Minnick. Mr. Minnick's my name. Math is my game. For this particular lesson, I am joined by one of the most exciting first period Algebra 2 groups I've had in my years here at GHS. So I'd like to give a shout out to them for being such a captive audience. The title of this should be Building a Tamaya Grasshopper. But it's not. But the title should be Building a Tamaya Grasshopper. The title of this is The Fundamental Theorem of Algebra, 5.6, The Fundamental Theorem of Algebra. I'm going to use a lot of big vocabulary words. Hopefully, if you don't know what they mean, somebody asks. Having a master's degree, I've written a lot of papers. Having written a lot of papers, I used the thesaurus quite extensively. So what I'll say about this, in addition to being, it should be titled Building a Tamaya Grasshopper, this is the culmination of everything we've done this year. This section is the culmination of everything we've done this year in class. We solved quadratic equations, we solved equations, we factored, we synthetically divided, we listed possible rational zeros. It's really the culmination of the things that we've done more specifically in Chapter 5 and Chapter 4, but we skipped Chapters 2 and 3. So 5.6, the fundamental theorem of algebra, is really about building a Tamaya grasshopper. I heard sweet. Yes, it is sweet. And I heard why. Well, a Tamaya grasshopper is what is known as a hobby grade RC. Now, I don't know if any of you are into RC cars or not. I actually bought the Grasshopper's big brother, the Hornet, because I always wanted one growing up, and I never had the money for it. And about 7 years ago, my wife said, well, you earned it, so we took our tax return money, and I bought one. How much is it? The car for the box and everything was $200, and then I had to buy a Futaba radio, and the Futaba radio was another $80. And then I bought a high, well, actually a low-turn engine or a low-turn motor for it, and then I had to buy a couple battery packs. So I had about $400 or $500 in it. It doesn't do anything. When you buy it, this is what it looks like. When you buy it, all you get is a box with all this stuff in it. A whole bunch of plastic and a whole bunch of pieces that you have to snap out, and decals that you have to put on, and a clear body that you're supposed to paint. And I ain't got patience for painting, I'll be honest with you. Mine looked horrible. It looked like crap. It was the ugliest looking car you'd ever want to see. But I did put it together the right way. And when there were pieces left over at the end, I just blame it on the person that packaged it wrong. Well, does it run good? Well, at the end of this, I'll tell you what happened to it, ultimately. But the point is, it wasn't a whole car to begin with. I couldn't drive it right out of the box. Nowadays, everything is what they call RTR, right? What's that mean in the RC world? Anybody know? Ready to ride, ready to run, whatever. So sometimes they even pre-charge the batteries for you. You don't even have to do that. But you usually are ready to run. You just pop the batteries in and you're good to go. This thing, when I unboxed it, it was like that. I had to snap apart the wheels and bolt the wheels together. Do you know how tiny those screws were for the wheels? Look at each wheel on there. There's 5 screws that hold them together. I might have parts and pieces of it laying around somewhere. If I do, I'll bring it in and show you. But that's what 5.6 is. Now, your society, my society, the society in which we live today, it caters to ready to run. When I taught freshmen, I used to really badmouth the drive-through. And you know what I do nowadays? I go through the drive-through. I hate it, though. I can't stand the drive-through. But the drive-through is being lazy. Well, I've got news for you. Tonight's homework. To give you an extra special incentive to try it, I'm going to make it worth 20 points. When I check tonight's homework, you should have at least 2 sheets of notebook paper, and on each sheet of notebook paper should be what we saw earlier in the week or last week with people having synthetic division about 17 times. Probably about 5 or 6 for each problem. Well, more than 17 times then. It's going to be a lot. Okay. When I put this car together, it took me 4 hours just to put the wheels together because those screws were so tiny. Now, one of these problems isn't going to take you that long. The rear end, take a look at the rear end housing. There's all kind of weird gears and stuff that go in there. I forgot to lubricate the rear end when I put it together. After I had everything all buttoned up, I'm like, oh, what's this tube of grease for? Oh. So then I had to take the rear end back apart and lubricate it and rebuild it all. Anyway, tonight's exercise is in 5.6 in this culmination of Chapter 5. The point that I want to make real clear, not only is the homework going to be worth 20 points, when I check it, I'm expecting to see sheets of paper with work on them. And if I don't, well, then I'm going to give you a 0. It's that simple. Because I'm going to assume that you copied off of your neighbor's paper. Or maybe not your neighbor. Maybe your cousin's paper. Or maybe your aunt's paper or your uncle's paper. So, here's the fundamental theorem of algebra right here. I'm going to see if I can't make that a little bit bigger. My magic marker will do what I am trying to get this to do. If I can make a rectangular shape around this, this will make it bigger. And you probably won't be able to read it. Maybe I better not do that. I'll read it. The fundamental theorem of algebra says if P of X is a polynomial, if P of X is a polynomial of degree n greater than or equal to 1, so they're saying it has to at least be linear, can't be constant. If P of X is a polynomial of degree n is greater than or equal to 1, then P of X equals 0. Then P of X equals 0 has exactly n roots, including multiple and complex roots. Basically, it says an nth degree polynomial has n roots. And we've seen that all along, but that's officially what the theorem says. Credit for the theorem is given to a mathematician by the name of Gauss. There's a lot of math ideas named after him. They call them Gaussian principles, but anyway, you don't need to know all that. So above that, they show you 3 quadratic equations, different ones, but all 3 of those quadratic equations have 2 solutions. One of them has 2 different real solutions. The other one has one repeating solution, or it has a multiplicity of 2. And then the other one doesn't have any real solutions. It's got 2 complex or imaginary solutions. So really nothing new so far, huh? So, problem 1 starts off like our Tamaya grasshopper with this parts page here. I'm going to cut that out. I'm going to go ahead and paste it right here. I said I'm going to paste it right here. Reminds me of singing Silent Night. Love that song. So that's what we got. We got an unboxed RC car with a trillion parts. Not a trillion, but a lot. We got a polynomial. Now, you might think to yourself, where do we start? Well, we could start by realizing how many zeros there's going to be. There's going to be 5 because it's quintic. Good. That polynomial is kind of small. If you're sitting in the Biak, you probably can't see it. So let me write it a little bit bigger. It's x to the 5th minus x to the 4th minus 3x to the cubed plus 3x to the squared minus 4x plus 4. Now that could be P of X equals, but they have it set equal to 0, which is fine. So we're going to need to start synthetic division. Maybe we should synthetically divide by 7, because I like 7. 7's a good number. -1? Why -1? Because I told you to, but how do we know that that's one of the possible rational roots? Sorry, my phone's ringing. I'm going to pause the video for a second. So if you're watching this back, my phone rang. No big deal, though. I like hearing the phone ring. It reminds me of the Wonder Pets. So what do we do before we can even know where to start dividing? We need to list something. All the possible rational roots using the possible rational roots theorem. So what are they? 1, -1, 4 and -4, and 2 and -2, right? Okay. Now, somebody suggested, because I suggest that we start with -1. So here we go. We're going to synthetically divide by -1. And I've got news for you. I told you about my Tamiya grasshopper, right? When I put the rear ends together, how I forgot to put the lubricant in there? Because it's just nylon gears. And if you don't lubricate nylon gears, bad things happen. Trust me. So anyway, I guess what I'm trying to say is take your time with things. If you synthetically divide wrong, chances are you're going to go down a path looking for things that you should have found long ago. Anybody ever lose their car keys or something like that? And you don't know where they're at. So you start moving things around, and you pile things on top of things, and you always find them in the last place you look. Think about it. Think about it. Think about it. You always find them in the last place you look. You always find them in the last place you look. Anyway, a lot of times you end up piling stuff on top of where they were in the first place, right? So take your time with the synthetic division. We got 1, -1, -3, 3, -4, and 4. Now, I know what some of you are thinking. Some of you are thinking, well, it's time for me to play Game of War because I really like Kate Upton. Well, that might be the case. But this problem is going to take, if we're focused on it, if we drink a nice, healthy, strong cup of black coffee, yeah, at room temperature, this problem's probably going to take 5 to 10 minutes. So coming in the next day and saying, Mr. Minnick, I didn't get this. I don't buy it because we have notes, because you have Khan Academy, because you have Math Excel that'll show you step by step how to do each problem, because you have 5 highly qualified math teachers in the building, because you have a study hall, because you have people like insert students' names. I could insert a few names. I could name drop. But I'm not going to. So here we go. We got 1, -1, -2, and 2, and -1, and 1, and 4. Let me slow my roll. Everything look okay so far? Okay. -4, -8, +8, and 12. Well, -1 didn't work. So that means I take the car back to the hobby store and get a ready-to-run car, right? Oh. It means I just go back to the drawing board. A lot of people want to erase this. Don't erase it. I'm going to be looking for evidence of this work. So don't erase it, but on the smart board, just for space's sake, I'm going to move that out the way. That would be so cool if you could do that on paper. If you have a tablet and you're working in a tablet, you could probably do that on that. So let's try +1 and see if +1 works. 1, -1, -3, 3, -4, and +4. So there's 1, there's 1, there's 0, there's 0, there's -3, there's -3, there's 0, and there's 0, and there's -4, and there's -4, and there's 0. That didn't take that long. So it's as if we have one of the sub-assemblies done, right? Thinking back to our hobby car, it's as if we just finished bolting together the front wheel. Yeah. They're not directional, so. We just finished bolting together one of the wheels. What do they say about the wheels? The wheels on the bus go round and round, round and round, round and round the wheels. Okay. At this point in time, we know that we're after zeros or roots. We know that there's supposed to be 5 of them. 1, 2, 3, 4, 5. We know that one of them is what? 1. Terrific. Terrific. My name's Barry Lakin. My name's not Barry Lakin. What I'm going to do at this point is a very good idea. You don't have to, but it's a good idea. So we started off with this big polynomial, right? We took that quintic, we divided it by a linear. Because one is a root, what do we know is a factor? Because 1 is a root, what do we know is a factor? Factors have an x in them usually. X minus 1, thank you. X minus 1 is a factor. So what I'm going to do at this point is I'm going to rewrite that 5th degree polynomial as the product of its factors. Well, we divided it by x minus 1, and so what's the quotient? We took a 5th degree and we divided it by a 1st degree, so it's going to be x to the 4th. How many x cubes here? Now, if you're not sure where we're getting these things, let me highlight this for you. This coefficient right here tells us how many x to the 4th we have, right? So there's 1x to the 4th. There are no x cubes. So what's our next term then in this quotient? 0x to the 3rd, but I'm not going to write it. Then what? Minus 3x to the squared. And then minus 4. Okay. Are there any questions about what we've done so far? Question. Where does the x to the 4th come from? So, really like these highlighting boxes here. We started off with this 5th degree, right? When we found out that 1 was a 0, that tells us several things. It tells us that x minus 1 is a factor. Make sense so far? Okay. So after we did that division, these, if you remember right, those are the coefficients of the quotient. So what we're saying is this 5th degree polynomial, could be rewritten as the factor, that x minus 1 factor, times whatever the quotient was. Well, these coefficients here give us the coefficients of the quotient. Does that answer your question? Okay. Okay. Any other questions before we continue? Well, I've got news for you. Some people call me the space cowboy. Some people call me the gangster of love. Some people say, Mr. Minnick, you're really good at factoring. And I'll say, you know what, I am. And because I'm really good at factoring, I can tell that I'll be done with this problem and the rest of it in a lot fewer steps than you. I am calling you out. I'm calling out every single one of y'all. Let's think back to World War II in Germany. What did the Germans use? They used U-boats. So what am I going to use when I factor this? I'm going to use U-boats. I'm going to use U-boats when I try to factor this x to the 4th minus 3x squared minus 4 equals 0. What am I going to let U equal? Not boats. What am I going to let U equal? I'm not going to let U equal 1. I'm not going to let U equal x minus 1. I don't even need to use U substitution because I'm good at factoring. I should be able to factor this. So I might not even need to use U substitution. It's 4 and 1. It's 4 and 1, negative 4 and plus 1, and what else? Not a couple x's, but you're close. X squared and x squared. Thank you. All right. Oh yeah, we factored some of those at the beginning of in 5.2. We factored those just like that. Now I'm good at factoring. I know what girls like. I know what type of polynomial that is. It's a difference of two perfect squares. So what's that factor into? X something and x something. X plus 2 and x minus 2. It doesn't matter what order you put the plus and minus in, but it factors into that, right? So from that, we get two more roots. Two more zeros. What are they? We get negative 2. And we get positive 2. And we're 3/5 of the way done. We passed. If you think about our grading scale, we passed. We could stop there. 60's good. 60's good. I can't believe how many people are content with that. I'm good with that. I don't know. Everybody's got different things, so whatever. But we got two more to get. And the two more to get come from this right here. X squared plus 1 equals 0, Mrs. Eckerdino. The I pops out. Yeah, that's right. So let's solve it. X squared equals negative 1. How do we solve that? Take the square root. Thank you for bringing your A game today. So it's I. But what do we need when we solve a quadratic by taking square roots? Plus or minus. So what we get is that x equals plus or minus I. So our other two zeros then are what? Plus I and minus I. And there we go. There's all 5 of them. Now how bad was that to do? Was it? How long did that take? About 10, 15 minutes? That's just like ordering Chinese food.
No, that's quick. Yeah, the Chinese food. Yeah.
Chinese food is rewarding? I love the taste of it. I could comment about Chinese food, but I'm not going to. Chinese food is I like the taste of it. And I'll leave it at that. All right. Well. Boy, that looks horrible. X to the 4th plus 2x cubed equals 13x squared minus 10x. I really hope that you encounter one of these in the homework. Why do I hope you encounter one of these? Because there's something obvious that isn't so obvious that even the best of students overlook. You have to get it all on one side because we have this thing called the zero product property, not the 13x squared minus 10x product property, the zero product property. So we got x to the 4th plus 2x to the cubed minus 13x squared. Minus 13x squared, and then what? Plus 10x equals 0. Now, how many roots, how many x-intercepts, how many zeros, how many solutions are we expecting there to be for our answer? 4, yes. 4 is a great way to start. There's going to be 4 zeros. I don't have to do any work because I'm good at factoring. You should be good at factoring. You should know what one of the zeros is before we do any work. Here's a 3-letter hint. GCF is a greatest common factor. Anytime you factor, if you can, you should factor out a GCF. So it would be 1 because it's x. It wouldn't be 1 because it's x, but because it's x, it would be something. What do each of those terms have factorable out of them? An x. So let's do that. So if we factor out a GCF, it's going to be x times the group of something, right? So because of the zero product property, that means that x equals 0. So what's one of our roots? 0. There we go. We didn't have to do that much work on that one. That's kind of like having our sub-assemblies already put together, one of them. Imagine if you had to assemble the motor. Anybody ever change brushes in a electric motor? It's tricky because you have to get everything lined up just right. And anybody ever time a two-stroke engine? Good. Anybody ever do what? Go off the road in the winter? Yeah. Anybody back their truck into their house yesterday morning before school started? So, so I didn't want to back into my wife's car, so I turned the wheel of the truck when I was backing up the icy hill, and the truck just slammed right into the house. No damage. The siding created a nice little buffer. So. Yeah, no, I didn't drive it, but it was by the kitchen actually. Interestingly enough. So, okay. So before we go talking about the icy driveways, we're left with this cubic to deal with, huh? So now we're back to that place that's next to Cuba. I think it's next to Cuba. What's next to Cuba? Huh? Not is Guantanamo Bay in Cuba? Let's think of that. It's a republic, not the Dominican Republic. Thank you, Puerto Rico. So what are our possible rational roots here? Puerto Rico's capital is, I don't know what it is. I should know. I don't know what it is. It's been a while since I've had geography. But what are my possible rational roots here? 10's one of them. Well, two of them, plus or minus 10. 1, 5, and 2. Muy bien. Whoa, too many commas. Too many commas. There we go. Well, where should we start? -1. That's a good try. A good way to start. -1 and a 1 and a 2 and a -13 and a 10. Remember, when you're synthetically dividing, when I check tomorrow's 20-point homework, I will be looking for evidence that you did this. Drop it like it's hot. -1. Oh, 2 plus -1 is 1, and that's -1, and that's -14, and that's 14, and that's 24. That's not going to work. Maybe I divided wrong. It's okay. So I didn't divide wrong. So what do we do now? Got to go back and try something else, huh? So that didn't work. So maybe we try 1. There's 1, there's 2, there's -13, and there's 10. And then there's 1, and then there's 1, and then there's 3, and then there's 3. Ah! And then there's -10, and then there's -10, and then there's 0. Good. I get so excited when they work. And it didn't even take that long, did it? What's my favorite part about math? When people have that aha moment. That's my favorite part about math. That oh moment. That's my favorite part about math. So again, it's a good idea along the way to rewrite this polynomial in terms of how it breaks down. So it was quartic, then we had it a linear times a cubic, so now it's going to be that x times something. Because 1 was a root, what's a factor? X minus 1, we're getting it, good. Good. Now, it was quartic, we divided out a linear, we divided out another linear, so we're going to have, we got an x here and an x here. So what's this x squared, good. Keep going. Plus 3x minus 10, and all that equals 0. Good. We're on to something. Now, I don't know if anybody notices on the back board, but there's some directions, and it's kind of erased, but it says handle the quadratic. You know, there's a certain point where you should be able to take care of some things. Like when you're 19, I heard somebody talk about this last night. A lot of people, they say, oh, I want to be out on my own. So they get an apartment with like 17 people, and they all live together, and they split rent, and it's like $25 a month rent, but nobody cleans. And nobody cooks, and nobody does the dishes. So there's, in the fridge, if you open it up and you pour out the milk, it comes out clumpy, and it smells like, you know what? In the cabinet, there's a whole bunch of jars of ravioli, because let's face it, everybody loves ravioli, Chef Boyardee. And there's Easy Mac macaroni, and when you make ramen noodles, you make them with the Keurig machine. It works, trust me. It's a long story. So anyway, where was I going with this? Oh, so you're 19, and you got all this laundry to do, and you spent all your money on ravioli and cheat codes for Game of War because you like Kate Upton so much. So what do? You go back home and you say, Mom, can you do my laundry? Take it down to the creek. I don't know about all that. Anyway, the point is, you should be able to handle this. We did this in 4.3. We did it again in 4.4. We did it again in 5.2. You should be able to handle that at this point. Can we factor that? XX. It's got to be a 2 and a 5. They got to be opposites because of the minus on the 10. So a minus 2 and a plus 5, right? Meow, we have the thing factored. Now we know all 4 roots. What are they? We got the 0, we got the 1, and then what are the other ones? Negative 5 and 2. Negative 5 and 2. How many problems are there going to be on the homework? That's a good question. So the last time we did the OOP homework, my one class did first period did the odds, second period did the evens, and fifth did the primes. What you're going to get is going to be the primes. First period will get the primes, second period will get every other, second period will get every other odd, and fifth period will get every other even, I think. So it's not going to be many. But remember, each one is going to be like assembling that Tamiya grasshopper. My Tamiya Hornet, I'll tell you at the end of this what its ultimate, what happened to it ultimately. So they're really cool. I tell you what, Tamiya makes a really great Toyota Land Cruiser. It was way ahead of its time. It had a 3-speed steel gearbox. Back in the day, they were like $600, but they're great. Anyway, so here we go. We got f of x equals x to the 4th plus x cubed minus 7x squared minus 9x minus 18. Now, we really don't have any freebies on this, do we? How many are we looking for? You can't factor an x out on this, but how many are we looking for? We're looking for 4. So I guess I got to start with Guantanamo Bay. Oh, no, that's Cuba. I guess I got to start with Wright-Patterson Air Force Base. No, that's Dayton, Ohio. What am I starting with? I got to list my possible rational roots, right? You don't have to, but you should. 1, 2, 3. That's plus or minus on each one of those. 6, 9, and 18. So I heard somebody say start with -1. Here we go. -1. And there's 1, and there's 1, and there's -7, and there's -9, and there's -18. So we got a 1, -1, 0, 0, -7. 7, -2, and 2, and -16. Now again, if it doesn't work, double check. Maybe you made a mistake when you synthetically divided. Maybe you made a mistake. Who knows? But I think that looks okay, right? Okay. You want to go to negative 2 next? I like to go in order. I mean, I like to be sequential about this. I'm going to go with the 1. There's 1, 1, negative 7, negative 9, negative 18. So here's 1. Here's 1. Here's 2. Here's 2. Here's negative 5. Here's negative 5. Here's negative 14. And here's negative 14. And here's negative 32. Oh, man. We got a mess. Have we found any bounds yet? What are we looking for when we look for bounds? All positives or alternating? Good. Yeah, so we haven't found any bounds. This isn't shaking up very well. I wonder how many times I'm going to shake it before. It's not shaking up like it's supposed to. I'll just group it like that. There we go. So 1 didn't work, negative 1 didn't work. Where should I go next? 32? 64? Negative 2. Okay. There's 1, 1, negative 7, negative 9, negative 18. There's 1. There's negative 2. There's negative 1. There's 2. There's negative 5. There's 10. Oh, this isn't looking good. There's 1. There's negative 2. And there's negative 20. Well, negative 2 didn't work. Something's got to work. 2? This is kind of like when you forget to put that lubricant on the rear end assembly. Let's try 2. There's a 2, and there's a 1, and a 1, and a negative 7, and a negative 9, and a negative 18. And there's a 1, and there's a 2, and there's a 3, and there's a 6, and there's a negative 1, and there's a negative 2. And there's a negative 11, and there's a negative 22, and there's a negative 40. Maybe it doesn't work. Maybe there's only one possible rational root. I don't know. Something's got to work. You want to try 3 instead of negative 3? All right, negative 3. Here we go. There's 1. There's 1. There's negative 7. There's negative 9. There's negative 18. I'm not getting the phone this time. It can ring. It's fine. There's negative 3. There's negative 2. There's 6. There's negative 1. There's 3. Oh, I think we might have it. There's negative 6. And there's 18. And there's 0. It finally worked. I love the sound of that phone ringing. Love that sound. Okay. I should. If it rings again, I'll get it next time. So what's my first root that worked? Negative 3. So negative 3 is one of the 4. So again, back to square one. Let's write this as, so f of x could be written as in factored form. Since negative 3 was a root, what's a factor? X plus 3, we're getting it. And then we took a quartic, oh, here's the phone. Okay, so we got x plus 3, and then we got x cubed minus 2x squared minus x minus 6. Right? So far, so good? Do we see where I got all that stuff from? Okay. Well. Look at what we have here. Shouldn't it be negative 3x? Did I write something wrong? Where at? Remember, we're adding down the columns. When I rewrote it, my coefficients are from right here. So I got 1x cubed minus 2x squared minus x minus 6. Okay? Okay? Well, I'm good at factoring, but you know that cubic doesn't factor by grouping, so guess what we get to do now? It's not quadratic, it's cubic. It doesn't factor by grouping, so guess what we get to do now? Not long division. We get to do what? We get to do synthetic again. We get to start all over again, but now with this cubic. So what are our possible rational roots here? They come from the 6. What are our possible rational roots? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now, did 1 work before? And we took our time with it, right? And is it going to work now then? No. What about negative 1? It didn't work either. So 1 didn't work before. 2 or negative 2 didn't work before. Did negative 3 work before? Could it work again? Hold on. What's that fundamental theorem of algebra says? It says including multiple roots. So what they're telling you is sometimes zeros repeat. I don't know if it's going to in this case, but sometimes they repeat. So the moral of the story here is that negative 3 might work again. So we're going to put negative 3 in a box, and here's this 1, negative 2, negative 1, and negative 6. Here we go. There's 1, there's negative 3, there's negative 5, there's 15, there's 14, there's negative 42, and there's negative 48. What do we know about negative 3 now? Not only it doesn't work, look at our entries on the bottom row. It's a what? It's a lower bound, so we don't need to worry about negative 6. Negative 6 ain't going to work. So what's next? Okay, positive 3. 1, negative 2, negative 1, negative 6. There's 1, there's 3, there's 1, there's 3. There's 2, and there's 6, and there's 0. So another root is positive 3. So rewriting this quartic then, we had x plus 3, x minus 3, x squared plus x plus 2. And all that's what p of x equals. Well, now we're to that one direction on the board. I said one direction. I said one direction. Handle that quadratic. Does it factor? I'm seeing somebody shake their head no. Whoever's shaking their head no, you're right. It doesn't factor. Quadratic formula, completing the square. Take your pick. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So that's negative 1 plus or minus the square root of 1 minus 8 over 2, Mrs. Accordino. Negative 1 plus or minus the square root of negative 7 all over 2, Mrs. Accordino. Negative 1 plus or minus I rad 7 all over 2. Those are our other two roots. You mean we're going to get imaginary roots? Well, what did the fundamental theorem of algebra say? There's going to be n roots when you consider that some roots are multiple and some roots are complex. There we have 2 complex. And they do show up in pairs. So negative 1 minus I rad 7 over 2, and negative 1 plus I rad 7 over 2. Those are all the roots. And that's it. That's 5.6. So you were asking about my RC car. I had a Tamiya Hornet. I assembled it. I drove it. My neighborhood people liked it because it was fast. It was really fast. And I made the dogs go crazy. It went about 28, which for a non-brushless motor RC is really fast. And so I took it to the skate park in Newton Falls, and I launched it off the quarter pipe, and it went about 35 feet in the air, and that was the end of it. I broke the rear end. The jump was sweet. I wish I had it on video. I probably could have jumped a house with it. So there are going to be a few problems where you might have to use a graphing calculator. Maybe. And we'll talk about those and tomorrow. So that's it for now. You'll have a couple minutes for me to pass out the homework, talk about the quiz from yesterday, and get started on the homework. So it's been real. It's been fun. I'll see you next time.